So this is the maths for titration 3, and the reason why I've picked this is that it was just an opportunity to do a different weak base. So our first titration, we used sodium carbonate, the anhydrous primary standard sodium carbonate, but in this one we are going to titrate it against ammonia. So normally we have been doing all boys sing well or all boys sing well bonus. And when we did it with the carbonate, that was this one because we generate CO2 as well. If you look at this titration, it doesn't follow either of these two acid-base type reactions, because even though this is my acid and this is my base, I am only making a salt, which is ammonium chloride. So this is Bronsted-Lowry definition of a proton donor and a proton acceptor type scenario, not a fully dissociate to make hydrogen or hydroxyl ions. So again, you have to generate your data table from whatever piece of information they're going to give you. We say attic is the weird number, basement is the whole number, so whatever it was you've titrated. And for us, it was in our attic was going to be the HCl. So you can generate this from their type of question. This is going to be the ammonia, the NH3. We want to find a volume, a concentration, and a big M. So when we did this, due to a typo in our textbook, we had a very small volume of this. So because this is a small volume, you need to be aware that there is a large percentage error. So, you know, one drop here makes a huge difference. So it would have been better if it was like 19.6, because then, you know, the percentage error is really small. So when you have very small, tighter volumes, you get this large percentage error. Our ratio is 1 for our HCl. We then had 25.0 pipetted. We're trying to find the concentration of our ammonia, and the ratio is 1. So this is our W. You're going to do this in the extra pages at the back of the book. This is going to be our way in. And when we do this, the attic is going to be on the left-hand side of this dotted line, and the basement maths is going to be on the right-hand side of it. So if we look, we said this is our way in. I always ask you to expand it, just so that you kind of get clear in your head that this is actually moles in 1,000 centimeters cubed. We know down at the bottom here now, or at least you should know, this is going to be in moles per centimeter cubed. When we go down, we know it's a division, so it's 0.1244 divided by 1,000. So when I put that in, however your calculator gives you, that is absolutely fine. As you know, I like scientific notation. So now we're in moles per centimeter cubed. We know we're going up. We know this flat line here is all about what's going on at the end point. So I need to work out my moles in 1.96 centimeters cubed. And to do that, I'm going to multiply what's down here at the bottom by 1.96. And when I do that to 4 significant figures, 2438 by 10 to the minus 4 moles. My ratio is 1:1, so that must mean I have 2.438 by 10 to the minus 4 moles, and I have that in the 25 centimeters cubed volume. So my next point that I'm trying to get to is going down. We know when I go down, it's a division. We know at the bottom it is moles per centimeter cubed. So now we have 2.438 by 10 to the minus 4, and we're going to divide that by 25. And when I do that, I'm going to get 9.752 by 10 to the minus 6. We know at the top up here is going to be our big M value. We know to go from moles per centimeters cubed by moles to moles in 1,000. Then I have to multiply that answer by 1,000, and when I do that, I'm going to get 0.009753 big M. So I've worked out now my concentration, so I've worked out that question mark value. It's going to fit in here. There is going to be something that says concentration in grams per litre. So when we are trying to do that, again, it is going to be, I have moles, I want to get to grams. We know there has to be a molar mass calculation involved to get there. A quick way or a quick piece of maths to do this is literally moles by molar mass is equal to grams if dimensional analysis is not your thing. I have NH3 is my formula. I have 14.01. I have 1.08 by 3. Put it into my calculator, show them everything. I get 42.36, and that's going to be what I'm going to use. So I had 0.009753 moles. I want to get rid of moles, so I have grams on the other side. So I'm going to put my molar mass on top and moles underneath and in my dimensional analysis cards, and now that's gone. And when I multiply one by the other, I will get, change the colour of my pen so you can see it, 0.4132 grams in a litre. And that should be a final answer. So we've talked about tactics. You do this in your extra pages. If you're not sure what they're asking for in the question, hopefully you are, you can just write C extra pages, or you can put in the answer in your little boxes. But I would also encourage you to put in C extra pages, because then if there's marks going for previous steps, you're going to get them. Okay, good luck.